Hello, everyone. Thank you for joining our online English meetup group. Today, we are going to talk about externalizing Runtime Fabric certificates in Mule applications in Runtime Fabric. Today, again, we have a special guest, Deepak. Deepak, if you want to go to the next slide. Deepak will be giving us a demo on how to externalize TLS certificates for companies who have security constraints or guidelines to, not associate their certificates with Mule applications. Before we start with the demo, I just want to give quick community updates and then hand it over to Deepak. Deepak, can you go to the next slide, please? Again, the agenda is we're going to talk about the guidelines for the meetup today. Deepak is going to talk about the different options that you have when you want to externalize certificates and properties for Runtime Fabric. Then we're going to do a demo, and we are going to end the session with Q&A if you have any regarding the utilities. Next slide, Deepak. So this is the organizing committee for the online meetup group. If anybody is joining for the first time, Manik and I are based out of US, and we help organize meetup groups based out of US time zones. Royston is based in Singapore, and Angel is based out of UK. So I'll be your host today, and again, nice to meet you, everyone. Next slide, please, Deepak. In today's presentation, if you have any questions or if you have any comments, please feel free to use the chat option. And anyone on the group, feel free to answer them or address them. If there is any questions that are not answered, I'll be asking those to Deepak at the end of the session. The recording of the meetup will be meetup groups page. So if you have any meetings and you need to drop early, you can always go back and look at the recording. Uh, and also it's also going to be available on the YouTube channel, which is called VirtualMuleys. If you have not subscribed to it, please do. At the end of the session, there will be a survey that we will send across to everyone who is going to attend today. Please do fill up the survey. It helps us really curate the content that you like, and then we also get the right speakers for our meetup group. Next slide, Deepak. Okay. In October, there are a lot of meetups happening. I know we are at the end of October, but there are still a few meetups that are going to go through in the next couple of days. Uh, Another notification is we are looking for speakers in some other groups as well. Mainly the meetup groups that are looking for speakers are the CMT group, the higher education and non-profit organizations. If you are working in any of these sectors and you have experience, handling complex architectures, please reach out to us using the links that I will be posting in this deck after the presentation, and we can get you set up for a meetup or speak at an event for us. If you want to receive RSVPs for our online meetup group events, please sign up for the upcoming events in our community page, and you'll get notified for every new event that we'll be posting. Cool. Next slide. Okay, so it's time for our meetup today. Deepak, if you have not seen Deepak in the community before, Deepak is a very valued member of our professional services team. He has been working with a lot of strategic accounts for MuleSoft, and he has expertise in RDF and PCE. So Deepak, over to you, and take it from here.
Hello, everybody. My name is Deepak Susilan. So I've been working with MuleSoft for about 4 years now. I'm a technical architect based out of East Coast. So like Sandeep said, I'm the lead specialist, one of the lead specialists for Runtime Fabric and PCE at MuleSoft. Okay, so shall we go ahead, Sandeep?
Yes, please go ahead.
All right. Okay, so the first is disclaimer, right? So what we are presenting here today involves some custom developed components, okay? They're not exactly part of MuleSoft product suite, and so they're not supported by MuleSoft support. The idea is that you would take this utility, tweak it according to your needs and own it in your organization. So if you need any assistance, it'll be limited to what we are presenting here today and what is there in the documentation. And you could always reach out to me also at professional services or your customer success representative. Okay, so the assumption here is that most of you already know what Runtime Fabric actually is. So we will not be going in depth explaining Runtime Fabric. So I'll just give a basic overview of what Runtime Fabric actually is. So Runtime Fabric is MuleSoft's container solution, right? It's a software appliance. It gives you the same experience as deploying your applications in MuleSoft's iPaaS Cloud Hub. So there are two versions of Runtime Fabric. One is the appliance, and the other one is you can deploy Runtime Fabric as part of a self-managed Kubernetes cluster, right? So in the case of appliance, we provide you the Kubernetes along with the as a software package, right? It's a gravitational cluster, and the Runtime Fabric components runs on top of it. In the case of self-managed Kubernetes, you will bring the Kubernetes cluster, and we will provide you the Runtime Fabric components that runs on top of it. So those are two basic flavors of Runtime Fabric. Moving on. Okay, so let's talk about externalizing certificates, right? So the one of the problems with using containers, like in Runtime Fabric, is that you would have to package the properties and certificates along with the application when you deploy. That's because unlike a standalone Mule runtime, you do not really have access to any of the shared drives, or you don't really have access to host path out of the box, right? So you would have to package your certificates and properties along with the application. So we get a lot of questions from our customers, especially the security engineering teams, mainly because packaging certificates along with your application comes with a certain drawbacks. Some are you cannot actually track your certificates. So you have thousands of applications in the organization. Everybody's packaging certificates with their application in the GitHub, and you do not have any visibility into who is using what certificate on, or when those certificates expire, or how you're going to automatically renew them. Most of the time, you know that your certificate renewed and your certificate expired when your application actually stops working, right? So that becomes a concern for your private key infrastructure, right? They don't have any visibility into what's going on, and you cannot even guarantee that all the certificates that are used are according to standards, right? A developer can go ahead and create a self-signed certificate and use it. And there are some security constraints. This has been raised by some customers that they don't really want to store their certificates in GitHub along with the source code. So what we are going to show you is actually three options to externalize the certificates with the Runtime Fabric application. The first option, this is the most commonly used solution for externalizing the certificates, right? What basically it does is you have a certificate stored as part of a vault or a certificate manager, and you would have the Jenkins build pipeline, which would take these certificates from the external store, from a certificate manager, and attach it into your deployable, like your deployment application. So you would probably unchar the application, copy it inside, and package it back and deploy to the Runtime Fabric. Right, this is the most commonly used solutions. You could use this method for certificates and property files and all those things, right? The advantage of this solution is that it does not involve any custom components, and your application is already packaged. You don't really have to modify your application after it is deployed. The container is still immutable. Some of the drawbacks is that once you package your certificates into the application and deploy to Runtime Manager, it actually goes and sits in Exchange. So for customers who are security conscious, who do not want their certificates and private keys to sit in any Maven repository. That is one concern. Second is that if you want to change a certificate somewhere, you would actually have to redeploy, right? So based on your organization, that could mean a change request. It have to go to release management. Redeployment generally goes through the release management cycle, right? So those are the two concerns which we have, which generally have with this solution. But nonetheless, this is the most commonly used solution. Okay. Do you want to take any questions on this particular slide?
Don't have any questions on this slide. We
All
can
right,
keep
let's go
moving.
on. Okay, this is option 2. The next two options are custom solutions. Okay, so this involves a custom component that we have built as part of services. It's in GitHub, and the link to the GitHub is on the slide notes, by the way. So you could take it and you could copy that custom component into your organization and use it. Like I said before, these custom components are custom developed and you have to own it. It's not part of the MuleSoft product suite. Okay, so this solution basically is using secure properties to store your TLS certificates and properties. Okay, so what it does is, same as before, you probably have a certificate manager to store the certificates and Jenkins build pipeline, or if you do not have anything like this, a cluster admin can go and create the certificates directly too. Basically, what we are trying to do is use the RTO-CTL. RTO-CTL is a command line tool that our Runtime Fabric provides. It has certain functions for updating secure properties, deleting them, viewing them, and a lot of other things. It's a utility tool. So you could use the RTO-CTL to actually create the certificates as a secure secret in your Kubernetes cluster as a base 64 encoded string. Okay. Once you do that, when your Mule application starts up, it'll have this custom configuration provider attached to it. So this custom configuration provider will read the TLS certificates from the secret and add it to the class path in the container. So the advantage of doing it this way is that you don't really have to package your certificates with the application, and you don't really have to inject the certificates when you package it. The certificate is injected during the runtime or the deploy time, right? Yeah, you could use this method to actually store both certificates and property files if you like. So some of the problems with the solution is that, well, the other advantage with the solution is that you don't really have to redeploy your application once you update the certificate. Okay, so your certificate is in a central place as part of the secure secret. Anybody can go and modify it once it is expired or before it expires, right? So see, most of the time, organizations have a very few number of certificates. Even if you have hundreds of applications, the number of certificates are very few, like 3 or 4 certificates, right? You could keep all the certificates as part of the secure secret. And you could, once it is about to expire, you can go and update those certificates in the secure secret without having to redeploy any of your applications. You would still have to restart the pods. You'll have to do a rolling recycle, but there's no redeployment associated with it. There are some downsides for this one. One is you could hit a size limit on the secure secret depending on how large your certificates are and how many are you storing. And the second problem is that a container is supposed to be mutable, right? So if you do it this way, you're actually adding a file into the container file system after it started up. So that is something which you have to consider. Any questions on this one?
No questions on the option 2. Maybe after the demo, we can circle back.
Yeah. Let's just go ahead and do a demo. I have to come out of the presentation, Sandeep.
Yeah, that's okay.
Okay, so if you can see my screen studio.
Yes, we can.
So there's a custom component. That custom component is called RTO Secure File Provider. Okay, it's also in GitHub. Here is where it is, RTO Secure File Provider, and we have instructions here on how to use it. Okay, So basically, the idea is you would take this utility, install it onto your local Maven repository, wherever it is in your organization, right? Or you can add it to Exchange if you like, and add it as a dependency to your application. All your certificates that you want to externalize, you would have to base64 encode it. Okay, you can use OpenSSL to base64 encode it, and then you would use the RTOCTL command line to actually add this certificate into a secure secret. Okay, each one of them you have to add that separately. I'll show you how we do that. And then in your Mule application, just the way you configure a certificate, you just specify the name of the certificate, right? And password and all those things. But the actual certificate does not exist in your application. And you would also need to have this RTF secure file provider custom component, and you specify the name of the certificate that you want to add. And that's it. Once you deploy, this component will automatically pick up that certificate from the secret and add it to the class path. Okay. So I'll walk you through a source code a little bit. Okay. So that the thing about this component is that you can easily extend it to support anything you want. Right now, the provider is a secure secret file provider. So this one reads the secure secret and adds your class path. But if you want, you can extend it to anything. Like you can read it from an external file path if you want, but you'll have to add support for that. Okay. So these two classes here, this is the component definition, basically. So you have a secure file keys and a file share location. You can use the file share location basically to read the file from a file share, but that is not implemented. You have to implement that on your own. Now we have this custom file provider and provider factory. Basically, this is an interface. So if you decide to extend this, maybe to use NAS, though you have to implement this method, copy file to target. So you'll have to read the file from there and copy the target. You'll get the target here, okay? Basically, target is the class path to where the file goes. These are the list of files that you want to read. So you read the file, take the list of files, iterate through it, read each file from the whichever store you want to read from, and copy the target. That's what you're supposed to implement. This is a provider factory. Basically, what it does is that it gets the path from the file path provider, and based on where you're reading the secret from, it reads the secret from that particular place. So we're only supporting secure secret right now. So that means I have the secure secret file provider. You can go into it. Basically, what it does is that all the secure properties that you add as part of the secure properties, all the properties that you add as part of secure properties are part of the system property. So you could actually read that key, get the base64 encoded value, and then decode it, right? And then add it to the class path. That's all what it does. Okay, I'll show you how it actually looks like. So I have this RTO secure file provider sample application. So this is a regular application. The only thing it basically does is it has a listener, it has a transform message, which actually just prints an output, right, in the JSON format. If you look at it, it's reading one property called as color, and the HTTP listener here has a TLS context, and it requires the certificate for the key store. Now, so there are two things. One is key store file, like the TLS certificate, and here's the configuration property. This is reading the pingable properties. This is the file that this application requires to be read. So normally the way you would do is you'll go to source main resources and add those to those certificate and the properties file here in source main resources and package with the application, right? But in this case, if you look here, we don't have those files, right? They're missing. So what is going to happen is that this RTO secure provider config here, this is going to read those two files. So you have the cert.ptol that is required by the key store and the pingable properties. All right, these two files are going to be read by this secure file provider. And the file share location is actually secure secret here. So basically, I'm reading from the secret. You can change if you decide to implement. Let's say you decide to implement NFS, right? You want to read from NFS. So you would probably do something like this. NFS path. Sorry, host path. You can implement something like this. So your implementation should go into host path and read these files. So that's how you can extend this one. Okay, so let's just deploy this application and see how it works. Okay. So I'm going to deploy this into appliance version of Runtime Fabric. So like I said, the first step, let's go to the GitHub and look at the steps. The first step is installing this, which I already did, adding the dependency to your application. I already did that. So I have this example application here in the pom.xml. This is the dependency for that custom component, Mule secure file provider. We already did that. Then we need to basis for encode both the property files, right? So let's see how we do that. So first of all, here, properties, space. I already have added these files here. I'm just going to delete them first so that we can, see how to add it. Let's delete this pingable properties first. Let's check the documentation. I have it here. Okay, address it will delete secure property and the key. Let's see. Right. So this is how we did it. Yeah, RTLCTL delete secure property, the file name that you want to delete it. So I'm just cleaning it up so that we can do it all again. Okay, so both are gone. Let's look at. Okay, so you can see I only have two. This is unrelated to this demo, but these are the two I have. I already deleted both of them. So these are the two files which we need in order for the application to run. So first of all, let's look at number properties. It has only one property in color green, right? So that was the color that we are trying to use in our example application. So here in this variable, we are reading the color, right? So that is here. So let's first base64 encode these two files, okay? In order to base64 encode it, we have to do this, use openness of the base64 encode. This is the first one, right? So we need to add it to the secure property now. So until CTO, apply secure key. You want to keep the key exactly the same as the file name that you want to use, and value is this base64 encoded value here, and the namespace. Okay, we updated the secure property with that one. Now we have to base64 encode our property file, that is ping out on properties. So this is what it is. We are going to do again RTOSCTL apply. The key in this case would be the same as the file name. So it is going to ping out our properties. Right. Let's go to secure property, apply key and value, right? There's the namespace. Okay, now let's look at the secure properties one more time and see if it is already, if everything is there. So we have the certificate here, and we have the ping out properties, right? So that should be sufficient for the application to deploy. We go back here, we export this application, and we try to deploy it. So I'm just going to deploy it to my endpoint management console. So I have two runtime fabric clusters here. One is the appliance and the EKS version. I'm just going to use it in the appliance. I have already deployed this application. I'm just going to delete it so that we can redeploy it. So it just takes a minute to delete that application, okay? Okay, so the application is gone. Let's just confirm it. All right, so that is gone. Okay, so let's try to redeploy the application. Okay, so this is the one, secure file provided sample, open it, increase, enable last mile security because it's running on HTTPS, so I just enable the last mile, and then we just deploy it.
Deepak, when you set the properties, you did not specify ID. Is there like a default ID it takes up?
When I specify the property,
If you just scroll up, I think you could find that.
okay.
Yeah. So you just specify the namespace, but you did not specify the environment ID. Is that okay?
Namespace is environment.
So, oh yeah, the environment ID is in the namespace.
Yeah.
Okay. Okay. Good.
Right. That's one thing you have to remember when you apply secure property. That's environment wide. Okay. It's not application specific.
Got
It's
it.
available to all the applications deployed in that environment. Right, so we have the application running right now. Right, okay. We'll just quickly test it. So this is the code I have for the appliance. You can see the property that we had in the application is already read, and it's also running on HTTPS. Um, so um, basically, both the certificate and property both are read from the secure property. Any questions on the demo so far? Now, let's say if you want to change the certificate, right? You can do this without actually having to redeploy the application. So let's say you're gonna file, change the color to blue, right? Once you do that, basically you have to go here and use the RTLCTL to delete that the old pingable.properties and um, install a new one. So we'll just use OpenSSL base 64. This is a new basis for encoded value. So we have to go to RTLCTL and delete the property. Um, Let me see. Actually, it's easier to just copy from the previous one and delete it. Right, so this is one we have to, okay, we deleted it, and we're going to apply this new value into the secure property. So let's go to RTLCTL apply. This one, we just have to change the value. Okay, we updated it. Now, how do we restart the application, right? You want to be able to restart this without downtime. The easiest way to do that is to do a rollout restart, but unfortunately in appliance, we are using an old version of Kubernetes. So the easiest thing to do is to patch the deployment like this. Okay, so once you patch the deployment, you can see that it'll just start it without affecting the existing one. So it's a zero, so a way of restarting the pods without any downtime. So once it comes up, you can see the property is actually the property change that we made is actually reflected here.
Deepak, we have one question. The curl command that you ran to test it, you ran it with HTTP.
Yeah, actually, it's the last mile that is HTTPS. In order for the HTTPS to work from the beginning, I need to have a certificate, which I haven't done. So once you install a certificate, it should work with HTTPS. But just for demo, let's try if it works with HTTPS. I don't think it works with HTTPS because I don't have a certificate actually deployed. Yeah, I don't have a I don't have the HTTPS enabled on the edge ingress. That's why I can't do HTTPS right now. But the thing is, the application is running. That means it's able to read the certificate. If you can't
Yeah.
read the certificate,
So
it will just fail.
Deepak, I think the port at the end of the URL, it's 80. You're resolving 80 port. That's why maybe it should be 443.
Oh, let's try. Right. That's because I haven't enabled that HTTPS yet. Let me see what's going on here. Right. So we have this new version of the application deployed. So let's just run this one more time and see if it actually. Okay, so the property changes reflected here. Okay. Yeah, regarding the HTTPS, guys, I haven't actually enabled it at the edge level. Only the last mile is HTTPS right now. So between the edge and the actual application.
Yeah. But so Deepak, if the properties or the certificate was not read, you would have received an error, right? If you
Yeah.
delete the property now, you should get an error, right?
Right. So let's say you delete it, right? Let's say you delete the certificate. Um,
Or the property. Yeah.
yeah, let's say you delete the certificate. Third dot virtual. Okay, the certificate is gone. So if you try to restart your application, it's just gonna fail. I can just directly delete the pod, you know.
Deepak, we have 20 more minutes. If you want to jump to the next option, we can come back to this.
Yeah, sure. Okay, guys. Yeah. So any other questions on this one?
I don't see any. If there is any, I'll take it at the end of the session.
Yeah, sure. Let's go to the next one quickly. All right. So this is a way to externalize certificates using custom admission controller in Kubernetes. Okay. Now, just a word of caution, right? We would like you to consider the solution only if you're familiar with how Kubernetes works, and if you're using the BYOK, like the self-managed Kubernetes version of Runtime Fabric, not the appliance one. Okay, because this is slightly complicated. If you understand how Kubernetes works, then you can use it. Basically, what it does is, let's say you have as part of your certificate management, if you're, let's say you're storing your certificates in a NAS or a EFS or a Azure file or somewhere, right? Like an external store. What it does is we create a custom admission controller. Basically, it's called a mutating webhook. Every time you deploy an application, it'll inject a persistent volume claim into that application. So it's a Kubernetes persistent volume claim. The persistent volume claim actually refers to one of the NAS or Azure file or EFS or anything like that, right? Anything that is supported. We are injecting the persistent volume into the application, into the deployment, runtime fabric deployment using a custom admission controller. So once your application is deployed, it will have access to any of these external file stores. Okay, whatever you store in it, your application can actually access. So this is a way of making your runtime fabric application access an external file store. So you can store your application properties or TLS certificates or whatever your application needs on this external store and access it in your application. Now, one thing you have to keep in mind here is that this particular webhook is actually written in Mule. You could actually write it in any language you want. Okay, it doesn't have to be Mule. If you write in Mule, then you'll have to deploy this webhook through any point platform. And one thing that you have to keep in mind is that this webhook becomes a critical point in your infrastructure. This always has to run. This has to be highly available and fault tolerant. That means you need to have multiple replications of it, because if this is not running, if the webhook is not running, none of the deployments are going to work, because you need the webhook to inject the persistent volume into a deployment for the applications to run, right? So if this is not running, then the deployments are going to fail. So let's see, it has all the same benefits as the previous options. You can completely separate the TLS certificate deployment pipeline from your application deployment, because the TLS certificate deployment pipeline goes through a completely separate Jenkins pipeline into the external stores. You don't have to deal with your application deployment pipeline. The TLS certificates are now stored as part of the application package. You don't have to redeploy applications. You can just roll out like I showed last time. There's no size restrictions like in the option 2 because the files are stored in external storage and there is no size restrictions. Now, some of the drawbacks are this is only for runtime fabric and self-managed Kubernetes. Like I said, the webhook is the most critical part of infrastructure at that point. It needs to be highly available. It's a mule application and it will utilize cores. So take that into consideration when you're doing sizing. You need to have pretty good knowledge of Kubernetes if you want to operate it. Okay. Let's go to a quick demo and see how that works. Now, the webhook is also on a GitHub repository here. It's called RTF Custom Admission Controller. And you have all the installation steps here. Okay, I'll go through installation steps so that you can understand the concept here. First and foremost is creating the persistent volumes. Persistent volume is a Kubernetes resource. Basically, you can add an NFS if you want. You can add an Azure file. You can add EFS. There are a lot of host of other things that is supported by persistent volume. Even host path is supported. Like in your Kubernetes cluster on the node, if you have a path, even that is supported. Okay. Now, you need a persistent volume claim to connect the persistent volume, right? The persistent volume claim actually refers to this persistent volume that you created. It is a persistence volume claim that you will attach to your application. Now, here is the webhook, right? There are some steps here. The webhook is a mule application, like I said, and that has to run as in HTTPS. In order for the webhooks to run in HTTPS, it needs a key store, right? That key store is actually signed by your Kubernetes cluster. So these are the steps on how to do that. Now, we have a script here. You can run the script to create the certificates for you. Now, pay attention to these two things, okay? Now, one thing you have to remember is that this webhook doesn't have to be deployed onto each namespace. It should only be deployed once to one of the namespaces, one of the environment, whichever you choose, that's fine. It will be able to access all the applications deployed anywhere else. So one webhook per cluster. In this case, I chose to deploy it into this namespace, this environment. And this is the name of the application that you're going to, this is the name that you're going to use when you deploy that webhook into Runtime Fabric. The name that I'm using is RTF webhook. You can change to anything you want, but don't forget to change it in the certificate. So basically what this does is this script creates a certificate with this DNS name, okay? RTF webhook dot this namespace. So if you change the name of the application, then make sure you change the certificate name. So this one will create a certificate for you, something called as keystore.ptol. You download the webhook from the GitHub and update the certificate here. Okay, the certificate will be specific to each cluster. So if you change a cluster, you'll have to create a new certificate. Now, after that, you create something called as a mutating admission controller. This is the admission controller that is telling Kubernetes when a deployment is happening, right? If it is for a mule application, then call this webhook. Okay. So when you deploy an application, basically what it does is, if it is a creator update, it will call this webhook, and the webhook will add the persistent volume claim or inject it into your application. So the webhook actually has two listeners. One is mutate, and one is empty path. The empty path doesn't really do anything. It just returns an OK. But the mutate path, so that path is actually used in the webhook. Okay, when you actually tell Kubernetes to use the mutating webhook configuration, you have to specify which service it is and what path it is pointing to. So the mutate, what it does is, Basically, it is modifying the deployment and adding a persistent volume claim into it. Okay. Once you deploy it, I can show you how it looks like in the deployment. Anybody who is familiar with Kubernetes would easily understand what this is. It's a JSON patch. Basically, it's an operation for adding a volume into your deployment. That's all what it does. Now, let's go into, okay, if you, right, from the previous demo, right, we can see that this didn't work because, in the previous demo, we deleted that certificate, so it just failed to deploy. Okay, anyway, let's move on to this demo. I have a different environment where I'm doing this. Okay, I'm just going to delete this test app. All right. Okay, so this is the RTF webhook that I have deployed that I was showing you. Okay, so I named this RTF webhook. That is the exact same name you used to generate the certificate. So that is running in one of the namespaces, right? Let's log into my cluster. This is my cluster, by the way. Yeah. Okay, so let's look at the PV and PVC first, right? NFS PV here, that is the persistent volume that I'm creating. This persistent volume is actually referring to an AWS EFS instance with the default path. In this this EFS instance, I have the certificates. Okay, so I'll just log into that and also show you that quickly. All right, so I have mounted that EFS into this path, and here you can see I have both cert.p12 and pingable.properties in this EFS volume. Okay, we'll log out of that. All right, now that is the PV or persistence volume. Now let's look at the PVC. Persistent volume claim is nothing. It just refers to the same persistent volume before. So if you're familiar with Kubernetes, you know that these two are attached based on the storage class name and the storage capacity. It's a 1 gig of NFS. This is 1 gig of NFS. So that's how they identify each other. Okay. When you deploy application, our mutating webhook here, mutating webhook here actually going to call the runtime fabric, that webhook application we created for every deployment, and then attach this PVC into it. Now, these things I have already described what these are in the documentation in the GitHub. If you go there, you can actually see what they mean. This is the CA bundle. You can get the CA bundle like this. Okay, so you need to, there are a couple of steps in deploying the mutating webhook controller. So it's all specified here. So that's why we stress that you use this if you are familiar with how Kubernetes works. Because you can do a lot of stuff with it. You can actually modify the deployments that is happening. All right, so these are the three main components in it. That's it. Once you have set this up, you can deploy your applications, and it will automatically pick up the certificates and everything from the external store. So I have this mutating webhook test app here. Now, if you look at it, this one doesn't really have any custom components in the application itself. You develop the application the same normal way you do. I have a TLS context here, which is actually looking at cert.p12. I'll show you what this is, okay, once you deploy it. And it's also looking for a property called pingable properties, right? So we're just going to deploy this application, RTF Mutating Webhook Test App. And as you might have noticed in the source main resources, there is no certificates and property files, anything like that. So let's go here. Sorry. Deploy application. Go into EKS. This is the Mutating Webhook Test App. Go to ingress. I already have all the ingress defined, so I'm not going to do anything. Just deploy.
Deepak, quick time check. We have 6 more minutes. We can go 5 minutes over maybe. Is that enough, the utility?
I think so. We're almost done here.
There was one question from the option to Deepak.
Yeah.
Is that utility compatible with UI OK option for RTF?
Yes, it will work for both. The option 2 will work for both. The option 3 only for BYOK. Okay.
So for option 3, Pawan has a question. So he's asking if this utility works after deploying our actual application to patch the
Yes.
service into the pod.
Yes, exactly. It works. So if you look at that, it is whenever there's a create or update of a deployment, this is going to get invoked. And it is going to attach that persistent volume claim into it. So the deployment is already happening, so I can actually show you the deployment, okay? kubectl-n namespace. Okay, so if you look at this, you see this one? We attach the persistent volume claim here into this. This is not out of the box in Runtime Fabric. So our webhook intercepted the deployment and attached this into it. And if you look at the volumes, you see this app data. So basically what it does is that persistent volume is being attached into this location inside the container. And we have exposed it as environment variable called as app data. So in your application, when you're referring to the property, basically you're referring to app data / winner. So whatever is there in your external store goes into this app data. Okay. So you can access whatever you like inside that, from inside that. Right. Right. Here's the volume mount. So the RTF PV person volume is being attached to the mule app data folder. Okay. That is how the whole thing works. So you can see the web application is already deployed and running. Okay. We can quickly test it. It's exactly the same as before. So this one is HTTPS. Here it's worked the same way. Exact same application as before. Same TLS certificates, and it picked up these certificates from this external store. All right. So any other questions on this one?
Questions, team? I don't see any questions. Looks like it was pretty straightforward, Deepak.
All right. So the order of preferences are like this, right? First one, if you can inject the TLS certificates into the application during the build time, use that. If you can't, you can use secure properties. It works on both BYOK and appliance version, but you have to keep in mind on the size limits of the secure secret when you're adding certificates. And the certificates have to be added to each environment because secure property is environment specific. Third option, basically using a webhook to inject persistent volume frames into the application. You could do this in BYOK option, and we would rather you do this if you are familiar with how Kubernetes works. Okay.
Yep, sounds good. Thank you, Deepak. This was very informative. I know there was a lot of content, good content that was shared. I posted the GitHub links in the chat. I'll also post it in the meetup page. So if anybody had to drop early, please catch the recording on our event page and also on the YouTube channel, which is VirtualMuleys. Uh, Thank you everyone for joining today's session. Everything will be posted on the event page. And thank you, Deepak, for taking the time and sharing this utility with us.
Okay, thank you.
Thank you.
Thanks for
Have a good day, everyone. Bye.